You've tuned in to our high-energy countdown of the best laptops for serious programming, and the excitement is real. From snappy compiles to all-day battery life, these choices are built to keep your ideas flowing without slowing you down. Today, I'm going to be going over the best laptop for programming that you can get right now. All of the products mentioned are linked in the description, so check them out if you're interested in any of them. With that, let's begin. At number 5, we have the NIMO 6850U. This model earns its place in the countdown by delivering a strong blend of raw processing power, fast storage, and practical daily usability for programming tasks. The heart of the machine centers on a modern multi-core processor that handles code editing, compiling, and testing with poise, while staying within a trim chassis that travels well between classrooms, coffee shops, and home desks. You get responsive multitasking when you open your editor, a terminal, a browser with multiple developer tools, and a local server at once, which means fewer context switches and more time actually writing code. The display is typically a bright, color-accurate panel that reduces eye strain during long sessions, with a comfortable 15-inch diagonally measured screen that balances code readability and portability. Fingerprint reader makes sign-in quick and secure, and the keyboard tends to offer a satisfying travel and tactile feedback that helps maintain rhythm during long debugging sprints. Storage is fast NVMe, which dramatically cuts the time it takes to install dependencies, pull down libraries, and boot virtual environments, while ample system memory keeps several heavy tools resident in memory without thrashing. Battery life is designed to cover workdays under typical coding workflows, using balanced power modes to conserve juice during light editing while ramping up performance for compilation and testing. Thermal design is oriented toward quiet operation at everyday workloads. You won't have to pause your flow as temperatures stay within comfortable limits. Ports are considerate and useful for developers. A couple of USB ports for accessories, a modern USB-C with power delivery for a compact external drive or monitor, an HDMI output for external displays, and a card reader that can speed up asset transfers without hunting for adapters. Wireless connectivity includes reliable Wi-Fi 6 that keeps Git push sessions smooth and cloud-based builds snappy. And there is often room to upgrade memory or storage to tailor capacity to your project. A combination of CPU performance, fast storage, and a capable keyboard makes the NIMO 6850U a solid pick for Python, web development, and light C++ or Java workloads, especially when you want dependable performance without stepping into high-end gaming specs. Compared to the Acer A315-24P-R7VH, which I have included as number 4 on this list, the NIMO 6850U offers punchier CPU performance and faster storage to reduce. At number 4, we have the Acer A315-24P-R7VH. This model is a compelling option for programmers who value an efficient balance of price, performance, and practical features that support long coding sessions. Beneath the lid, you'll typically find a capable mid-range processor that handles daily development tasks with ease, whether you are editing, compiling, or running lightweight virtual environments. RAM configuration often starts large enough for comfortable multitasking, and there is usually room to upgrade, which is a big plus for developers who like to squeeze extra headroom for large projects and virtual machines. Storage is fast enough for smooth system boot-ups and quick project loads. You can often configure with a sizable NVMe drive that gives you fast access to code repositories, Docker images, and dependencies. Display is commonly a 1080p panel with good legibility and decent color, which translates to less eye strain when you're staring at lines of code for hours. The keyboard experience tends to be reliable, with a travel that helps you type for long stretches without fatigue, and the touchpad is precise enough for precise edits and navigation. Thermals are designed to handle everyday workloads without becoming a distraction, although in intense builds you might hear a gentle fan tune, which most programmers learn to tune out. Battery life is practical for a full day of development work in many scenarios, especially when you optimize background tasks and keep power settings sensible. Build quality feels sturdy for daily transport, and the chassis typically remains cool to the touch as you alternate between browser tabs and the terminal. Developers who collaborate and share screens, the integration with external displays via HDMI or USB-C is particularly helpful, letting you extend your workspace without sacrificing portability. Wi-Fi connectivity keeps cloud repos accessible, and the system often ships with a reasonable pre-installed software suite that assists with wireless debugging and development tasks. In short, the Acer A315-24P-R7VH offers a cost-effective foundation for programming, with strong endurance and upgrade options that help you scale as your projects grow. Compared to the NIMO 6850U, which I have included as number 5 on this list, the A315-24P-R7VH excels on value and keyboard comfort. while the other emphasizes raw processing speed and storage speed for faster builds. Number 3, we have the Acer A315-24P-R7VH. This model nails a slightly different target by leaning into gaming-style performance and a robust cooling system that also benefits programmers who run heavier workloads, like data processing, local machine learning DMOS, or large-scale builds with transportable test environments. Discrete graphics option, when present, gives you a responsive desktop feel for tasks that can leverage a GPU, such as rendering previews, training lightweight models, or simply accelerating multitasking with GPU-accelerated browser tabs and developer tools. CPU and RAM combination supports smooth editing across multiple editor panes, terminal windows, and virtualization software, letting you allocate resources to different containers or virtual machines without constant swapping. Display quality on these units is typically strong, with a bright panel and high refresh rates that can improve fluidity when scrolling through code and documentation. And the color reproduction helps with tasks like UI design, prototyping, or front-end work. Cooling is a priority in this class, so sustained dev sessions tend to stay comfortable and quiet, allowing you to focus on logic rather than heat. You'll also find practical durability for transport between campuses or co-working spaces, a feature many programmers appreciate when taking a laptop on the go for code reviews or hackathons. Battery life remains capable, letting you work through a long afternoon or evening of code, debugging, and refactoring sessions, especially when you tune down energy use for prolonged runtime. Expansion options, including additional memory and storage slots, give you space to grow as your projects demand more resources, and the overall system is friendly to Linux installations, which is a plus for developers who prefer open software stacks. Presence of multiple ports, stable wireless connectivity, and a solid keyboard layout makes this model a reliable partner for developers who like to mix game-inspired performance with serious coding discipline. Compared to the ASUS E1504-33, which I have included as number 2 on this list, the A16-32P-39 prioritizes performance, headroom, and cooling efficiency, while the ASUS leans toward compact value and portability. At number 2, we have the ASUS E1504-33. This budget-friendly option is all about delivering essential programming performance without unnecessary frills, so you can focus on writing code rather than chasing clock speeds. CPU is capable enough for everyday development workflows, including editing, compiling, and running a localhost server for testing. And you typically get a practical amount of memory that supports multiple tools at once. The emphasis here is on efficiency, so the system remains responsive during daily tasks, and the keyboard quality is often comfortable enough for long typing sessions, which is essential for debugging and writing documentation. Storage options are adequate for starting projects and managing dependencies, with room to upgrade as your needs grow. And the overall system is designed to be lightweight for easy portability between classrooms or co-working spaces. Display brightness and clarity are sufficient for long coding sessions, and the panel tends to stay legible in typical indoor lighting, which reduces eye strain during marathon debugging marathons. Battery life is a practical convenience, especially for students or professionals who work in cafes or libraries, and the chassis is designed to stay cool enough for comfortable hand placement during extended use. The device usually supports a broad range of software tools common in education and entry-level development, and Linux compatibility is generally good, which is a strong point for developers who want to experiment with open-source environments. For those who occasionally push the limits, the ASUS model may be outpaced by machines with larger CPUs and faster storage, but it remains a strong baseline for coding tasks, note-taking, and light testing. Compared to the Acer A15-32P-39, which I have included as number 3 on this list, the ASUS emphasizes portability and budget efficiency, while the A15-32P-39 offers more performance headroom and cooler sustained workloads. At number 1, we have the Snapdragon A16-11M-X0LW. This is the standout choice for programmers who prize extraordinary battery life, quiet operation, and constant connectivity while you roam between cafes, libraries, and co-working spaces. The ARM-based design delivers a different efficiency curve from traditional x86 laptops, translating to longer daily usage between charges and a quick resume from sleep to productive work. For many developers, this means you can carry a single device to classes or client meetings and still have enough power for scripting, coding experiments, and light container work without needing to hunt for a power outlet every few hours. Windows on ARM brings a modern software ecosystem to this platform, with native mobile-style performance for many productivity apps, while x86 emulation provides broad compatibility for popular developer tools, though you may encounter occasional compatibility caveats with very specialized desktop software. Keyboard remains comfortable for long sessions, and the screen size keeps the device easily portable without sacrificing legibility or readability for code and terminal windows. Wireless and cellular connectivity options can be a boon for remote work, while a streamlined chassis keeps the device lightweight for travel and fieldwork. Thermal behavior is typically very quiet, a virtue when you want to focus on writing code, review pull requests, or run lightweight experiments while commuting. However, the trade-off with this architecture is that some powerful desktop-grade tools or certain virtualization setups may require emulation or alternative tooling, which can add a layer of complexity for advanced workflows. Storage and memory configurations, when available in this class, generally emphasize efficiency and reliability over raw peak performance, which can lead to snappy boot times and smooth handling of everyday tasks, but might be more cautious during heavy compilation or large dataset processing. In short, the Snapdragon A16-11M-X0LW excels at mobility, long battery life, and a clean, distraction-free environment for coding on the go, making it a compelling option for students and professionals who value portability over peak raw horsepower. Compared to the NIMO 6850U, which I have included as number 5 on this list, the Snapdragon option prioritizes endurance and mobility, while the NIMO is built for speed and multitasking headroom.